Hello, this is John from caveofprogramming.com. In this video, we're going to take a closer look at lists in Kotlin. So we've seen lists before briefly, but we'll do a bit of a deeper dive on them, and we'll also take a look at filtering and mapping. So you might think in Kotlin that you would create a list by creating a new list class of some kind. Let's create numbers1 here and set it equal to. And now we don't want to use list directly because this is just an interface, it's not a class. But we can use array list, and we have to say what type of thing is in it. So let's say that this is going to contain ints. And that's fine, we have now created a mutable list. However, if we want to initialize the list, let's maybe call this numbers1, we'd have to add items to it one by one with add like this. And that's all a bit unwieldy, and that's why instead, if we want a mutable list, it's much easier to just use mutable list of. And this is a function in the Kotlin standard library, so we don't need any imports for it. It's part of the general Kotlin codebase. Let's add some numbers in here, just kind of randomly. And you can see that that's obviously a lot easier than doing this and repeatedly adding all the numbers that you want. And if we want a list that can't be changed, so it's not mutable, we could just use list of. Under the hood, that might still use array list to implement it, but our list is going to end up not implementing the mutable list interface, so we won't be able to change it via the actual variable. Lists have lots of very convenient and useful methods. To get the number of items in the list, I can either use the size property, so numbers2, let's say, .size, or I can also alternatively use the count method. And if I run this, I find that there are 6 items in my list using either of these methods. If we've got a list of something that can be added together, we can also sum them up like this, let's say numbers2.sum. which might be quite handy from time to time. So the total sum here of all those numbers is 26. To loop through the list, we've already seen one way of doing this. We can write for, let's call it num in numbers2, put some brackets on there, and then I'll just do print line. In fact, I'll do print, and let's print out each number using $num with a space after it, and then underneath that, to create a blank line in the output, I'll just put a print line. So if I run this, here's all the items in my list printed one by one. But if what you want to do really is just to print the list so you can just look at it, it is easier just to do print line numbers2, because the string method, the toString method of the list, gives us a perfectly acceptable readout with a couple of square brackets around it to emphasize that it is some kind of sequential list of numbers. However, there is another way that we can print a list or iterate through it in general, and we can do it using a kind of functional style of programming. So I could say, for example, we'll use numbers2 again, .for each, and here I need to supply some kind of function which will operate on each element. So one way of doing that would be to use a function reference. If I have 2 colons like this, I can put, for example, print line. So we've got a function reference to print line, and if I run that, print line is going to get past each of the elements in turn, and it's going to run on each of the elements. But let's spell this out a bit more fully. So another equivalent way I could do this, if you remember lambda expressions, is so every lambda expression has curly brackets around it, and I could get the element to refer to using it, like this. And if I run that, you can see this also works. We've got the numbers printed out one after the other again. In fact, now I have the opportunity to put a bit of formatting in. Let's put double quotes around this and use $, to interpolate the value into the string. I'll change this to print, and we'll have a print line underneath it so that we have a blank line in the output. And now if I run that, now they're all printed out on one line. But if you remember the trailing lambda syntax that we've looked at, we don't actually need these round brackets when we're supplying a lambda expression as the final argument to a function or a method like for each. So we can actually remove those round brackets and use trailing lambda syntax like this. And if for some reason we want to actually name this argument instead of using the default it, which is how single arguments are supplied to us in lambda expressions by default, we could actually write x, for example, arrow, and then I can refer to x in here. So this lambda expression is getting passed the values from the list one at a time. It ends up here in this lambda expression argument, and then we just print it out. And you can see that works perfectly well. But usually if you have only got one single argument, it makes sense just to use it, so we could just use it in here instead. If we want to get the index of each element as well as the actual element, we could do it using a different method. We could use for each indexed like this. Let's get rid of those round brackets. And then we have two arguments. We have the index and then we have the item. So I could use the index here if I want in my string to say what index each item is at. And then if I run that, actually that looks a bit of a mess. Let's get rid of this space here and then I think it will be readable. Yeah, now we can see that, for example, the number 4 is at the index 2. There are other methods that we can use with this functional style. If I want a sorted version of my list, I could do it like this. Let's say val numbers3 equals numbers2.sorted, and then I'm going to print numbers3. And you can see we've now got the items sorted in our default order. We can also sort with custom comparators, but maybe we'll take a look at that later on, because otherwise this video is going to get a bit long. If you want to sort in reverse order though, let's take a quick look at that. You can just use sorted descending, and then it's going to sort in the reverse of whatever the default sort order is for the items in your list. Another thing we can do is map the items. So let's say val numbers4 equals numbers2.map, and here I can supply a lambda expression that will supply a mapping. In other words, it will change each of the items to something else. Let's get rid of those round brackets and put in curly brackets. So the easiest way to do that would be, for example, here I could say it multiplied by 100, and that's all I need to do. Let's print out numbers4 and take a look at it. So I run it and you can see we've multiplied all the items here by 100. I should put print line there so we get this output on different lines down here. But this is what we're looking at right now. So here again you have a lambda expression that just takes one argument. So I could write x arrow equals x times 100, but it's easier just to write it times 100. And another thing that we can do is supply a filter. Let's duplicate this, and instead of map I'm going to use filter, and we'll call this numbers5. Notice we're not changing the original list, we're just creating new lists. And here we have to supply something that will return true if we want the item to be in the list that's returned, and false if we don't. So for example, we could say it mod2 equals 0. In other words, if you take the remainder after dividing each item by 2, if it's 0, so this whole expression will be true, then we will include it in numbers5, which will print here. Otherwise, this is going to be false and we won't. So we're basically creating a list of just the even numbers. And here you can see we've got just 4 and 8. Let's print the original list above this so that we can see that indeed it hasn't been changed by doing sort or map on it. And we'll see that indeed 4 and 8 are the only even numbers in that list. So here's my original list. You can see that the map didn't affect it. And we've got 1, 5, 4, 8, 5, 3. So the only even numbers in there are just 4 and 8. Okay, that's it for this video. I've been trying to think what's left in Kotlin that we have to cover. I definitely am going to go over maps and sets, and maybe we'll take a bit of a more complicated look at sorting. For example, if you've got a bunch of objects that you want to sort in a custom sort order. I don't think we've covered abstract classes, so we'll have a look at those. And we need to take a look at scope functions. If there's anything else that you know about that you want me to cover before I finish this course, then do let me know. Otherwise, I think there's maybe 5, 6, 7 videos left, something like that. And then we've basically gone through pretty much the whole of the fundamentals of Kotlin. I am going to be creating a Kotlin for developers course. That's going to be kind of like this, but I'll go at a much faster speed because it won't be for complete beginners. It'll be for people who already know some programming. And my plan is that at the end we'll take a look at how to put together an example Android application, because I have finally managed to update my computer to something that can actually run Android Studio. And I'll probably make some more free Android videos for my channel also. So if you're interested in any of that, don't forget to subscribe. And until next time, happy coding.